today I'm going to be talking about explaining the lesson of 7.1, which is the nature of chemical reactions. So when you first hear the word chemical reaction, what do you first think of? So labs. So
Scientists.
yeah. So when you first hear the word chemical reaction, you might think of labs, laboratories, chemicals, scientists. Chemical reaction is when these substances are formed by chemical bondings. For example, ripening, you have here some types of apples. Like if you leave an apple for like 1 week or 2 weeks, it will start to ripen, as you can see here in this picture. And also another example of chemical reaction is decay of leaves. When you leave the leaves outside and you don't plant them for a long time, they will start to decay. And also burning the paper when you light a match and then you put paper to burn. So there are more examples of chemical reaction, but those are some examples of them. For example, here we have an apple, and some examples for chemical reaction for an apple is ripening, as you can see in this picture. Also, you have here wood, and another example of chemical reaction to wood is burning, which forms ashes, as you can see in this picture. Some signs of chemical reaction. There are a lot of signs that show the chemical reaction has occurred. Some signs, they are formation of gas. So as you can see here, the vinegar and baking soda, when you add them together, the baking soda will react with the vinegar, and it will cause this gas, as you can see here, it forms and rises up to here, it's carbon dioxide. So the first one is formation of gas. The second sign of chemical reaction is the formation of solid or precipitate. So as you can see in this picture, here like powder is created here, which is solid, or in other words, you can call it also precipitate, as you can see in this picture. The third sign is formation of energy. So as you can see in this picture, when the chemical reaction happens, the energy that released, as you can see here in this picture, as explosions or other examples. But there are more types of there are more signs of chemical reaction, but those are the main signs of chemical reactions. Other signs might include the formation of light, formation of heat, and formation of sound. And every chemical reaction, there are two main things: reactants and products. The reactants, they are what atoms together, what they react together, and the product is what gets released or what gets formed after. So for example, here we have isooctane, which is the CaH18, and oxygen. When they both react together, they're going to form carbon dioxide, water, and also they release energy. So when you add isooctane with oxygen, they are both called reactants. They react together, and then you get, as a result, you get carbon dioxide, water, and also you get your energy. Those are called the products. Energy must be added to break bonds. For example, if a chemical reaction cannot happen without energy. For example, isooctane and oxygen. If you went to a fuel station to add gasoline to your car tank, by just putting gasoline into the tank, it might be so dangerous if the energy must not be added to chemical reactions. So that's why nothing happens. But the energy must be added, like finding a match to gasoline and oxygen when they react together. So as you can see, like when so many times when gasoline is poured on the ground with oxygen, and you fire a match on it, it will start to burn and become. So here you don't have energy, and they don't react. While the other one, they react and they cause like fire and explosions. Forming bonds release energy. So as you can see here, the same example of isooctane, which is CaH18 and O2. So when you get the products, which is CO2, H2O, and energy. The products here, they are CO2, like you have CH and O. The CO2, the type of atoms, they don't change, like no new atoms are formed. Like here you have C, here's C, and O is oxygen, there is oxygen here, and hydrogen. There's no like iodine or other types of atoms. And also energy is released. So in every chemical reaction, when you form bonds together, energy gets released. So in a chemical reaction, energy is conserved. So energy cannot be created or destroyed due to the low conservation of energy. And the energy, you might think of the energy of explosions, you think that the energy is created, but the energy is not created. The energy is taken from the energy from the bonds between the atoms. The energy between the bonds of the atoms is called the chemical energy. So the chemical energy is the energy from the bonds between the atoms. Then the energy between the bonds, which is chemical energy, changes form into other types of energy. So what's energy? So then when the bonds get broken down, as you can see, the chemical energy they increase, which is the bond between the atoms, and then when they are formed, so the chemical energy, which is the bonds, they change form to heat and light, as you can see here. So that's why you see like explosions and fire released. There are two types of reactions, exothermic and endothermic. The first one is exothermic. But all types of combustion is an exothermic example of chemical reactions. So because exothermic means that in the chemical reaction, the energy gets released. The energy gets released. So here, as you can see, combustion is the burning of fuels. So as you can see in this picture, the fuels getting burned. What's released is oxygen and heat. Heat is one type of energy. So energy here is released. The atmosphere. Another type of reactions is the absorbed energy, which are endothermic. So as for the surfaces, the plant they take the energy from the sunlight, and to make their food and oxygen and release energy. They don't release energy; they just take energy from the sun to make their processes. And also in baking, you can't bake bread, for example, without using the energy, which is fire from the oven. So you use the heat from the oven to bake the. And also in cooking, you might use the gas to cook eggs or other examples of food. So energy here. It was absorbed and not released. Well, it's endothermic. But the other one is exothermic because the energy was released at the end of the chemical reaction. Thanks for watching and listening. I have a nice
You know how sometimes you go to bake a cake, but your banana's all gone rotten, your utensils have rusted, you trip and pour all of your baking soda into the vinegar jug, and then your oven explodes? My friend, you and your chemical reactions have fallen victim to enthalpy and entropy.
They are from the same types of atoms. So, for example, what is formed is CO2, so like C and O. Like no new types of atoms are formed, and also H2O, which is water. So the types of atoms they are the same, but the bond they are mixed, like separate, different from the reactant.
And entropy at play when you go to light a campfire to cook dinner. Your match has enough energy to activate the exothermic reaction of combustion, converting the high-energy combustible material in the wood to lower-energy carbon dioxide and water. Entropy also increases and helps the reaction along because the neat, organized bar of wood is now converted into randomly moving water vapor and carbon dioxide. The energy shed by this exothermic reaction powers the end.
So here the burning of wood is an example of an exothermic reaction because the energy is released as heat.
Endothermic reaction of cooking your dinner. Bon appetit.
And at the end, what I have to say is now the chemical reaction is here, the example of chemical reaction that I stated here, and exothermic and endothermic, they both show you how different types of chemical reactions happen in our daily lives. And I hope you understood the lesson. Good luck.